All right, so let's talk a little bit about the article again. So because it has a couple of interesting points. So the first one was the need for some breakthroughs in material science and so on. So we sort of skipped that. It's a little bit beyond what we kind of do in this course. So let's talk a little bit about paging. So how does that work? So we talked a little bit about push messaging before, right? On last week we talked a little bit about push messaging and how it is sort of important for the mobile technologies, and when you're developing a system, there are kind of offerings which do push messaging for you. So how is push messaging different from the paging the article talks about? What do you think? So any of you played with BIOS in your workstations? Do you have workstations at home? Do you play with BIOS? Set up some parameters in your BIOS? Have you seen something which is called wake on LAN?
Yes.
So what is that?
Allows to power on the computer with some line signal.
Right. So you have a computer. It's plugged to power, but the computer is not powered, right? It has a network interface connected to Ethernet, and what happens is you can tick that on. You can tick that on, and what it will do is there is a special packet which the what is this here? What is your computer connected to?
It's a network.
To a network via a switch or a router. So there is a certain packet the switch or router will broadcast, and once it hits the network card will wake up the whole computer, will power it up, right? So how much power is the computer using when it's in the idle state?
Only for the network card.
Only for the network card. So it actually uses almost none, because all the power it needs is sort of the computer only needs to power the network card a little bit to be listening to that kind of that particular packet, right? So this is how the paging is different from push messaging. And push messaging, we still have to have the full stack active all the time, right? To get the messages out, to get the information about something into the system. With paging, we don't. So in your stack, so in here we have the physical layer, and then we have the data link layer, and then the data link layer wakes everything up, right? So the network card cannot process packets which are not data link in the idle state. It can only process packets which are in the data links layer, and the particular packet wakes things up. And then it wakes everything up, and we have the application layer and say HTTP up, and then we can process the HTTP requests, right? So if it is, if let's say you have a webcam at home, right? So you can wake up your computer, take a photo from the webcam, send the photo to you, and shut the computer down, right? So you took a photo, you send it to yourself on the mobile, and you shut the computer down, and the computer is down again and waits for the wake-up call, right? So you paged the computer, it woke up, it fired up all the processing stack up to HTTP, it took the photo, it sends you the photo over HTTP, and then it shut itself down, and it idles in that state, right? So it idles in the data link layer, waiting for the wake-up packet. And the wake-up packet is kind of like a paging packet, right? It's like the paging protocol. So the push messaging kind of works here, and it requires all the stack layers to be up. The paging model doesn't. The paging model is designed to work on a lower layer so that it wakes other layers up if necessary, right? So the paging will wake up your GSM module to allow you to make a call, but if you are not right now making a call, you don't have to have it active, right? So you have a certain stack here, like in GSM as well, and the paging works on the kind of a lower layer, and then your GSM calls are sort of done somewhere up, and then if you are paged, things fire up, and you can take a call or make call. If nobody calls you and you call nobody, then you're sort of in that idle state here, and the high-level modules, high-level hardware doesn't need to work, right? So the paging is an interesting concept because it pushes things down to the more data link or physical layers and allows the application layers to be completely idle and not to use the battery, right? So we talked a little bit about that when I drew the protocol stack and said, well, we kind of try to push things down into the lower layers of our software or networking stack. And the interesting thing here is that we kind of don't have the technology to do that on the internet. So you have wake on LAN, and the wake on LAN works on the Ethernet layer, on the MAC layer, right? Your switch has to collaborate with you to wake you up, right? Or you have to have another computer which will sort of wake that computer up. But you can't go and say wake on WAN, right? You don't have that. You could have that if you instruct your router or your switch to wake your computer up if it receives a certain packet from the internet, right? So this is your gateway to the internet. Here you are within LAN, and then through your router or through your internet provider, you go out to the wider internet. But you can't wake your computer up from your mobile phone if you are outside of your LAN, right? Because the routers don't know how to wake things up. We are missing that technology. We're missing the way we can do stuff locally to be kind of able to do them kind of on the wider internet. So this paper talks a little bit about that. It says we need to have some ways on the internet to put things into idle state and keep them idle if they are used and wake them up when we need them. So this is what the paging and the kind of a network communication protocol are about. It leads to routing though. So as you were saying, the default mode is if you on, you are reachable and therefore you work properly and you operate properly. If you switch a router down or you switch part of your network down, that means it's down. It's broken. It will not be usable. So the paper talks a little bit about the telecommunications companies. So if you have your end users talking through the ISP, right? So you talk to your particular ISP, and then the ISP talks to some telecommunication company, right? And then the telecommunication company makes all the traffic being routed, and then at the destination, it sort of reaches somebody else's ISP, and then your information kind of travels there. So the paper was saying these guys who own kind of a large chunk of the network, if they have a busy day, they will have multiple routers which route traffic to in multiple ways within their network, right? So that is quite complicated, and they have different paths to reach particular destinations. But at night, when the traffic is very low, they don't need that complexity. They can say, okay, we actually turn off these guys, we know this guy is on, and we know this guy is on, and we can route everything through there because we don't need that capacity, and we don't need to keep everybody up at night, right? So they fire things up when the demand is there, they fire things down when the demand is not there, but this happens because they own the whole network and they know who is on, who is off, and they kind of plan it in advance, right? So this is possible. This energy efficiency scenario is possible within a particular telco because they own every of those nodes, and they know which ones are on, which ones are off, and why. And they know what the routes look like if a particular node is off, right? But can we do that on the internet if it is not owned by one single entity? What if this is just an internet? And if some nodes go on and off depending on the traffic and the bandwidth requirements, and we know if this node is off, it's not because it's broken, but because we're just making energy savings. This is not possible at the moment. So the paper kind of discusses that and says, well, to have the paging working really well, we have to first fix the routing problem to make it a little bit more robust. And it is an open question. Like, we don't know yet how to do it efficiently. So that was one of the main topics, which was the paging and the routing. They kind of come together because it is, in theory, it is possible to keep the nodes idling and to keep the nodes sort of off. But if they are off, if the end user devices are off, that's not the problem. So the end user devices, the mobile devices, can be off, like with the wake on land sort of situation, and you can page them even through the push messaging to make them kind of download the content at a particular time. So they don't have to do busy polling. They can pull when the information is available. So we discussed that last week. We can make those end user devices idle even better if we can push the push messaging down to some of the lower layers of the networking stack. So if the push messaging doesn't happen on the internet layers, it happens on the GSM layers, then we can be woken up by a GSM packet, like with the actual paging for the calls. So if the GSM paging could wake up our internet stack, we could be even more efficient because we can turn our Wi-Fi off and we can turn our data off, and then when we get an email, we could get a GSM page packet telling us you should fire up your Wi-Fi or network data connectivity and connect to that particular resource. That is not there yet, but we may kind of achieve it relatively easily. But achieving the ability to turn on and off the routers and then reroute the routes, that is kind of tricky because everybody has sort of a route table, and then if my routing table tells me to push the packets, if the destination is there, to that next hop, and the next hop is off, then I don't know what to do, right? I have to find out how to update my routing table if the particular nodes are on or off. So that needs to a different solution, which is based on the content delivery network. So in the content delivery network, I don't care about the routing tables. I only care about the content of where the content can be obtained, right? So if this node requests a particular content, and the content is delivered from that node, and that node has a routing table and it knows, okay, I have to put information there, we have a routing problem. But if that node knows it needs a certain content, and it knows that this content is available there, or here, or there, then it can get it from the closest source around. And we don't care about the routing, right? Because this is sort of a more content addressable routing than peer addressable delivery network. So the difference is we either know where everybody is and how to reach everybody, or we know where everything is and how to read it, right? So the difference with CDN is that we don't care from where it comes. We just care what comes to us. So there is a, so they kind of talk in a paper as if that is not really a solution, but it is a solution. There is a company called Akamai. Have you heard about this one? So you should definitely know about this one. So you should Google it, or you should go on Wikipedia and read about it. What this company does, it basically created a content delivery network for the internet. So they support big broadcasts companies. They support anybody who needs reliable, fast access to content anywhere in the world. So they have their own data centers. They have their own kind of a content replication mechanisms. And if you want your customers to reach your content fast and reliably and on time, you usually will use there are other companies which do similar thing, but that's the biggest on the internet, and a lot of big broadcasts kind of go through that. So for example, if you go on eBay and you make a purchase on eBay, your transactions will go through Akamai. If you need any newspaper or any news aggregator, almost always the big ones go through Akamai, right? So you don't access the resource the way the normal internet works. You access the resource the way the content delivery network works, right? So you say, I want to see this web page. So you say to eBay, I want to see this web page. And eBay will not show it to you. It will be the Akamai showing it to you from the closest source they have to your destination, right? So if you're accessing it from Jovik, they probably have a Norwegian data center which caches all the pages which you made requests from eBay, and then they will show you those pages. You will not talk to the US servers. You will talk to your local servers, and it happens transparently. So you don't actually notice that. Your addresses get translated, and it just works. So this is one of the solutions for the content addressability of the internet, but it doesn't solve the energy inefficiency issue, right? They still have to build the data centers. They still have to do it relatively statically, and they still have to kind of keep powering it up, even if people don't use it. So it solves the addressing issue, and it makes the content delivery much more efficient, and in a way reduces the energy consumption. But it's not the ultimate dream of being able to address anything on the internet in a fashion which is sort of content addressable. So yeah, so check these guys out and check how they started and how the whole model works, because it's very interesting. Okay, so we kind of talked a little bit about the paging and the kind of waking up. We talked a little bit about the routing and the problems associated with the ability of turning nodes on and off, which are sort of part of the routes. And we talked a little bit about that the content addressing solves the issue of routing because we don't care what the routes are, we only care where we can get a particular content, a particular semantic information from. So we had, in the previous university, we had a project which was to make, this is a little bit messy here. So the thing is, if you have a PC and the PC is connected to power, but you don't want to use the power if you don't need it, and you have your the network card, and the network is using the wake on LAN, then your switch or your router needs to know how to do that if your friend wants to push you a message, right? So if this is a let's talk the same scenario as I discussed before, right? So you have a mobile phone and you want to see what happens in your house, what is happening, so you want to take a photo. But you don't want the device to be on all the time. You only want the device to be on when you want to take a photo. So the ideal situation would be you send a certain request to your router at home. So your router has to be on all the time, right? Something has to be on somewhere. So if your internet provider or your router at home allows you to send the information over the internet and use that to wake your device, then your device can make the photo and use HTTP to send you photo back and then power itself down. So that would be the ideal scenario. But so up to here, this is solved. This is the problematic area. How to make it so on LAN we know how to do it. The trick is to make it possible that you can do it sort of over the internet. So if we have, so that's one scenario which we discussed, and the other scenario is you have your servers. You have some sort of a servers which talk to the mobile device, and currently if we use push messaging, then you have to be operating on the higher levels of communication. So you have to have a Wi-Fi, or you have to have a 3G or some other data connectivity available for the push messages to actually work, right? They are short, but they are still requiring your client, your mobile device, to have that stuck on, right? Which is expensive. So the paper talks about how different is it to have the 2G on, the normal GSM on, compared to having the Wi-Fi on, or 3G on, right? So let's have a quick look what uses the phone resources. So if you check now what uses the most battery out of your phone, what that would be? Screen. Yes, screen is number one almost always. What's next?
GSM audio could be.
Yeah.
Wi-Fi general LCs.
So screen uses the most. So what's the solution to that? Keeping the screen off, right? So if we don't need to have the screen on, then the screen is off and the phone still does what it needs to do, right? So if I have a running app which records my RAM, I don't need the screen on, right? So the screen is off, but the app still works. It still does what it needs to do, right? So keeping keeping screen off when we don't need it is the only solution for that. Having some tactile feedback. So if you get an email, you can vibrate the phone. So you don't need to have the phone on with the screen on to tell you, oh, you've got an email. You can have a tactile feedback from your pocket. So on the laptop, we usually have the screen on, and then we have a pop-up dialog box telling you got an email, right? But it's energy inefficient to keep the screen on. So we get the notification in a different way. We get the notification via tactile feedback or a sound. All right, so the next one is, what do you think? Is the 3G or Wi-Fi taking more energy out of your phone?
So when Wi-Fi is on, so it's Wi-Fi probably. But overall, for example, my phone, since it's most of the time it's in standby, so the GSM module it takes more energy. So it is constantly on.
Yeah. Right. So here we have the GSM, kind of the voice module, right? Without the data. So here, without the data, GSM is more efficient than 3G or Wi-Fi. You can make an experiment, right? You can turn your, so you have the ability to measure how much battery you have, right? So you can have how much battery a certain thing uses. So you can go onto 3G and watch a video for an hour only on 3G with Wi-Fi off, and then you can go on Wi-Fi, turn the 3G module off, turn the GSM off, and watch that video for an hour again, right? Then you can measure how much battery you've used. So if you do that, what do you think the result would be? The 3G uses more or Wi-Fi uses more?
If we play it again?
Yeah, so it's the same video for 1 hour. This one is with 3G off, only Wi-Fi is on. And this one is Wi-Fi is off and only 3G data is on. Which one will use more power?
Wi-Fi.
So who thinks 3G? Who thinks Wi-Fi? Right, so according to the poll, majority think it will be Wi-Fi. So you can try it, right? You can make an experiment and try it with your phone. It depends, right? Different phones will behave differently. The phones which we've tested indicated that 3G uses more and Wi-Fi uses less. The Wi-Fi module was somehow more efficient than the 3G module. So these two are kind of close contenders. You can check for your device what it is, but one of them will be more efficient than the other. But they are kind of close, right? Then we have the just GSM, which is always better, right? So if we have a push messaging which works here, it's less efficient than if we had a push messaging or paging done just here, right? So it would be nice to have push messaging or paging done here to wake these things up and possibly to wake the screen for things which we need to interact with.
And also GSM is constantly on.
Exactly. So this one is on all the time, and we kind of don't really want this to be off, right? Because then you lose the paging, the low-level paging, so people can't call you, right? If you turn that off. So normally this is on, and we don't want this off. So that's the kind of the lowest level of being on. And everything on top of that should be optional, right? So your Wi-Fi and your 3G should be optional. So it would be nice if we had push messaging or paging for the internet services done on that layer. All right, so what else uses battery? What else do you guys use? GPS? Accelerometer? Gyro? Sorry? Yeah. So the operating system, we kind of can't turn that off either, right? So that one is on and will be on no matter what. They do optimizations themselves, right? So they try to make it efficient, and they try to make it sort of nice and energy efficient, so we don't have to worry about it. So that one is on. So we have other things. What else do we use on the phone? Perhaps. Yeah. So the GPS, so for location, you can use GPS. What else can you use for location?
Triangular.
Yep. So you can use the GSM and Wi-Fi. Right. So which one is the most expensive? Wi-Fi.
And GPS also.
And GPS is better than Wi-Fi, but it, again, this one is on all the time, and so on.
Yeah, and most of the time when you use GPS, you still have to have Wi-Fi on. So there is access to GPS.
Yeah, yeah. So there have been a little bit of work which has been done in that as well. So Google tries to optimize the energy efficiency and balance the accuracy by using all three, depending on what is available and what gives you the reading. And also, sometimes you kind of don't really care about the battery that much. You just want the fix now. You don't want to be there for 5 minutes and to kind of do it in a very energy efficient way. You kind of say, well, I would like to know right now where I am on the map, roughly. I don't need super accurately, and the time is sort of an issue. So balancing those constraints here is a little bit tricky. So what happens is they've changed the API a little bit, and they kind of let the system to make more decisions depending on what is on and what is available for the developers. So again, yeah, as we were discussing, so you have your apps, you have your operating system, and then you have your hardware. And it's kind of the OS together with the hardware deciding on how to do this efficiently, and your app shouldn't really, your app should use the API which the operating system exposes, and the operating system will do kind of the rest for you. So there's been a little bit of changes in the 4.3, I think, and 4.4 of how this is done and how this is done internally for the developers to make it easier. All right, so that leaves us with the motion recordings. So in the older phones, the chips which were used for the acceleration and gyro recordings could be turned on and off depending on the state of the phone, right? So they, like for example, in that phone which lies by the laptop, that's the HTC Desire. The accelerometer is part of the chipset which is responsible for the display. So the display being off forces the accelerometer to be off as well, right? This device physically can't record acceleration if the screen is on, if the screen is off, which makes a problem, because if I want to have a step counter, then I have to have on this particular device a screen on to be recording my steps, and that's not useful because I will be doing it with the phone in my pocket. I don't need the screen on, and the screen is the one which uses the most battery, so that creates a problem, right? So these low-level sensors there is always a bit of a tension of making the hardware decide of when things should be on and off, and when you should decide when things should be on and off. So here we know that being idle on the hardware level is always the most efficient, right? So if the hardware can turn things on and off for us, that's always the most efficient. The next step is the OS, and then the app are the least efficient. So it's the same with the networking stack and who decides about waking up whom. So the hardware in that particular phone decides when the acceleration should be recorded or not, and the decision was made based on the state of the screen. So they assumed that if the user turned the screen off, the user is not actively using the phone, therefore some of the sensors should be off, which in case of the activity tracking and using acceleration and gyroscope for activity tracking is not a good decision. So in the newer phones, we have the same problem, and in the newer phones, the acceleration and gyro on the hardware level will actually be on all the time. They are on by default, and it doesn't cost the battery much of the energy usage to have them on all the time. It's the way how they are kind of configured, how frequently they do the readings. So again, it's good to keep the hardware and the OS sort of deciding when things should be on and off. So there is with low-level sensors, we also have an issue of we have to pre-process the data. So we discussed that in the first lecture when we talked a little bit about quantified self, that the trend now is to have so you have the CPU, and normally the CPU has to be on to process some of the low-level sensors data and let the OS decide what to do with it. But keeping the CPU on in the idle state is expensive. So it's easier to have a coprocessor, which is a specialized chip, being the one responsible for pre-processing the raw sensory data, to keep the CPU off if we are in the idle state. So in the idle state, the CPU doesn't need to do anything. The data is being kind of recorded and processed by the coprocessor, and then the coprocessor can decide when to wake up the OS services, and then the OS decide when to wake up or where to transfer the information up to the higher level of our app components. So the idea is that the low-level sensors will talk directly to the hardware coprocessor, which will decide whether the wake-up needs to be happening or not, right? And then the hardware is the one which is the most efficient in the idle state. So it is a little bit like paging. So the sensors kind of page the coprocessor, and then the coprocessor decides whether the app has to be notified or whether the OS needs to be notified, right? Okay, so we kind of covered the most of the ideas and most of the things which the article talked about. So what are your thoughts about that? What do you think could be done when you're designing your system to make it more energy efficient?
Well, seems like it requires serious change. For example, we have to rewrite whole TCP/IP protocol to make it possible for energy efficient, like on LAN, but be in large scale.
Mm-hmm.
And same for this routing problem. So BGP protocol.
Yeah.
Yes, it kind of handles routers going up and down.
Yeah.
redundancy and stuff, but for energy efficiency solutions, when we turn down the router ourselves, and it would send some kind of signal through this table, so that other routers can delete it from the table. Because now it is done just by polling every 2 minutes by default. So yeah,
That's the rewrite the entire protocol to just build like that's a failure.
Exactly. Yeah. So some of the changes are beyond the developers. Like you can't really do that, right? So you can't really change the way things are wired up currently, because it would require rewriting the entire routing protocol and the way the routing tables are updated. But for some things, you can try to push some of the things into the lower levels of your design in such a way that you keep the minimum amount of things up in the idle state, and you kind of do the actual work when it's needed to be done. So even with the push messaging, even though the push messaging is not efficient and it happens on the higher, internet layers, you can still make your app more efficient by pushing some of the things to be triggered by the paging mechanism instead of you polling or checking it yourself. The other thing is, and it was discussed in the article a little bit, is that, and we discussed it before too, that your app should pretty much do nothing if you can get away with it, right? So that the moment that you don't need to do anything, you should not do anything. The moment where you don't need a screen, you should be able to turn the screen off.
It's about paper down. When you code an app, you should avoid like libraries and polling and that kind of stuff and other programming.
Yeah, that's right. So there are some guidelines which we can sort of follow when we're designing systems, and we should keep an eye on the developments in the protocols and the protocol stack of what is happening. So in IPv6, they have mechanisms for making the nodes a little bit more mobile and still addressable. So there are already mechanisms for helping nodes to be on and off, and in a little bit more robust and flexible fashion compared to IPv4, which doesn't have that mobility built in. All right, so let's talk about the second paper. So what are the main points of the second paper, and did you like it?
Always great variety of different methods to generate power without batteries.
Right. So the first paper was all about, okay, the battery technology, the material sciences, and the way we utilize the batteries. The second paper is, okay, imagine that we don't have a battery, how we will power things up, how we can generate energy for things to work. So what are the methods and what are the limitations? What do you remember from?
I remember him covering probably 50 different things, and though in smaller number of categories.
And so making it clean.
I also had some formulas concerning voltage stuff that I kind of just skipped over. But he had like mechanical stuff in the
Yeah. Was to use the human motion to generate the energy, and roughly speaking, what was the shoe capacity sort of to generate, depending on the weight and the activity?
It was 250
to 700
megawatts.
Yeah.
And 60. I don't remember what was it between the way of working.
Yeah, so that there are some boundaries, but
I think more than 2 watts if you were going.
yeah, exactly. So 2 watts is quite a lot, right? Yeah. So how much your phone takes? roughly speaking. If you have your screen on and you're using it.
On my laptop takes 10, 15
watts.
Yes, and it's a lot.
Yeah.
So probably takes 1 to 2 with screen on.
Yeah, so probably with everything on, it would be around that level. Without Wi-Fi and data, probably less. Yeah.
Also talks about the fact that humans actually walk in the device short scale.
An estimate of you like starting to sprint and how much energy you generate by a short burst of sprinting, and that is like kilowatts. It's big, but we can't tap to that. So the efficiency is relatively low, right? So what else? Heat engines. You remember the heat engine efficiency, and how does that work? It's quite small because the heat engines are relatively inefficient. It's like 5% or something can be utilized, and they work on the principle of the differential between temperatures. So exactly. So your like the difference between your body temperature and the ambient temperature, right? So that is a good idea. It's a little bit tricky to tap into that. Solar panels, yeah. So solar panels, there is quite a lot of innovation in that area. I've seen phones with the solar panel on the back, which are not used completely to power the device, but to recharge the battery. There is new materials and new more efficient way of building those. So that is a possibility, although they also did compare the sun outside ambient light and the indoor kind of office light. And the office light was much lower than the outdoor sunlight to power to generate the power. Okay, what else?
About how watches work.
Yeah.
Safety, it's an exhaust and stuff.
That's right. So that was all about the micro generation of energy based on some fuel burning or and there are some risks involved, especially with microelectronics. There was an interesting one about the radioactive decay, which also can be used to generate, and you have the waste to deal with, and it is inherently risky. So the watches, yeah, and the micro vibrations, those are quite good. So there was an example of a car having some flapping thing to power the braking electronics. So that is possible. You have to generate enough vibrations to generate the current, usually through some coil moving and yeah. What else was interesting?
More efficient if it's actually resonating.
That's right. Yeah, if you reach the resonating frequency, then it's the most efficient point. What else do you remember? So which of these do you think will make their way to mobile devices?
Nothing to be approved.
So the solar already are kind of prototyped. What else?
Even if it doesn't charge it all by itself.
Yeah,
Just
but extends the.
yeah.
No, I think human-powered like voyage rate fits quite nicely with the wearable electronics. That's it. So maybe not directly mobile, but if you have some smart shirt or something, and it would be reasonable to target with smart shoes.
Yeah.
What they did mention, the old shoes they tried were like cumbersome and big, bulky sneakers, like
Yes. So the old versions were based on some mechanical forces spinning things and so on. So there was a mechanism in the heel which could kind of spin some things, or the one on front. The modern version is using a form of a liquid which you push through as you step from the heel to the toes. So there is a kind of, imagine like a gel sole, like in the sports shoe, where you put the pressure, it kind of forces the gel or the liquid to go from one place to the other. And that moving of the liquid inside your sole propels some generator. And that is much more feasible technology and less cumbersome, and it would probably work quite well if they sort of improve it. Yeah.
I like the idea of crank for a laptop.
Yeah. So there are some handheld torches and things where you use you crank some sort of generator for a while to charge it.
There are even like toy chargers where you can spin the handle and charge your phone.
Yeah. So how about the ambient radio signals to be used for energy?
Is there enough energy in here for mobiles?
Yeah, so the article was claiming there isn't enough because of the regulatory concerns about the power of the emitters. Yeah.
Otherwise, people might get cancer.
That's right. So the ambient radio signals which we can use are too weak. There is possibility of having a specialized kind of a radio signals like with RFID tags, where you have the receiver and the RFID tag.
It certainly work in things that require exactly no amounts of power, but work on laptop.
Exactly. Yeah. So
requires quite a lot more energy.
That's right. But the idea is that you could potentially use that for the lowest level of the idle, just to keep, some things up for the system to wake up. So there has been we had a student who was working on RFID tags, the active ones and the passive ones, and he was sort of doing a research on what technologies can be used for long-term deployment. So, for example, you want to build a bridge and you want to put some RFID tags in the bridge to measure some of the tensions and some of the forces inside the bridge, but you're not gonna ever replace them. So once you put them in, they will be there for 10, 20 years or 50 years. And you want them to keep working during that period. So what sort of technologies you could use for powering them up and then letting the sensors read the status of the bridge. The passive ones are kind of a good way to go about it, because you can always generate energy externally and then power them up to read the readings that whatever they measured inside the construction. Yeah.
kind of human body energy. It was interesting project some time ago. It's like energy awareness project. They made lamps that were powered by blood. So it had some kind of chemical inside, and you had to the lamp was single use, and to break it from top, then puncture your finger, drop the blood inside, and then the iron from blood came into reaction with the chemical inside. The lamp started glowing for an hour or so. It was not practical, but
just awareness
yes.
rising. Yeah. So what other means they were using in the article? There were some chemical ones mentioned as well. All right. So how did you like the two articles? How would you compare them?
The first one was better.
Yeah.
It was more focused on some particular problem, and it was easier actually. The point of the second one had a lot of sort of information.
So both were kind of survey papers. They were overviewing some of the developments in those different technologies. So they were bringing in information from multiple contexts and referencing others people work. But the first one was a little bit more focused, whereas the second one was broader, more sort of everything possibly can come in. So some of the. So what else? What else did you think? Did you do you think the first paper stated a problem and sort of provided some direction, whereas the second didn't?
Well, the first one certainly has some points which you can follow. So, and the second one is just stating, okay, there is this frustration. And it's because the second one is more like really hardware solutions and more further from what we do. There is no clear understanding what we can do to this kind of
First one, it also had quite a bit of history and all that stuff, and spends quite a lot of time discussing quantum computing issues and stuff. I guess it's relevant for the energy-saving problems in general, but it's very hard for me to on the whole platform actually mention about that.
Yeah.
That would be something, I don't know, IMT4093 and those guys might do.
Well, the second article has a bit of history as well, for verification.
Yeah, it's the second one. It's like they just go through a large list of items.
Exactly. So that, so I also think the first one was better, and I think the second one is usually how we write literature review things, right? So it's a bunch of things which are kind of not directly connected and are dealt individually. So they did have, for example, with the shoe, they have this history, they discuss how things were, the heel and the toe kind of models, and then they say, oh yeah, the breakthrough is now with those liquid-based sort of more less mechanical devices because they can be easily fitted. But it's sort of a self-contained unit. It has nothing to do with the article, in a sense. So then you have few of those self-contained units described in the paper. and there is nothing really which connects them all as such, because they have that similar theme. They're about powering electronics by human power or whatever, but there is nothing which connects the shoe, for example, with the radioactive decay as such. Those are completely two separate research areas, right? Whereas the first paper, it was also a review, and it was also a sort of different technologies, but it had kind of a common goal, and the different means of achieving that goal were kind of explained, and the historical perspective was common to all of those, right? And they had this sort of a common theme. So when you're writing your work, the tendency is to do this kind of a partitioned perspective on various things, and you explain this, and you kind of put some arguments for it, and then you jump to the next thing, and it's sort of, it will look like the second paper. So sometimes it's unavoidable. Sometimes you do that, but the ideal would be to do it the way the first paper did it. So you have a certain objective which is common, and then you kind of investigating the same objective from different angles. But you always have the same objective in mind. The objective for optimizing the shoe energy generation and the radioactive decay energy generation, they are completely different. They are not the same. There is nothing in common between these two things. So probably they shouldn't be in the same paper. You probably should have them in different papers if they don't have that much in common. And it is a hard task. So the hard task is to have a well-defined, clearly defined objective of your research, and then look at it from different angles, but always look at the same problem, and try to solve it via different means. So the first paper sort of succeeded in that, and the second didn't. It was a little bit more partitioned and a little bit more too broad for the topic. So each of those tiny items is an interesting item, like the how to make a shoe-based energy generation possible. It is a research question, and you could make a paper out of it. You could use historical overview, how different approaches were made, how current approaches are done, and what possibly can be done in the future, and what are the challenges, what are the problems, and so on. And that would make an interesting article, but it's kind of a topic on its own. If you combine multiple topics in a single paper, then you become sort of like a supermarket. You don't have a specialized focus. You kind of not focus. And then if you have a non-focused paper, usually it's a bad paper. It's really hard to have a good non-focused paper. So when you're writing your own papers, when you're writing your own thesis, or when you're writing your own report, try to think of just one thing, one topic, and write it for that one topic. It's not easy often. It's kind of easier to say, oh yeah, I have to write about that, I have to write about that, and I have to write about that, right? And you kind of do that. And then at the end, you may end up with a nice paper, or you may not. So kind of trying to refocus your idea early on, and trying to say, okay, I'm kind of writing about that. Is this relevant, and how it is relevant to this? And then what is this? How this relates to this? And you kind of always put what you're writing about in the context of that one theme, of that one topic. Then it will make the paper better. It's not easy. You will fail. You will write things about different things throughout your writing, but at least you kind of remember the ideal, that what should the paper look. So I thought, yeah, I thought that was interesting to compare those two papers. The other thing was how the references to other people research were done. Have you noticed the difference between the first paper and the second paper?
I noticed in the first paper that it says example, and it was number 3 behind. But the next time you refer to it, it says the 3, and I found that confusing Who was the 3 again? Oh wait, who's this? What?
Yeah, that's right.
I found that a bit confusing.
Yeah, so that was a little bit confusing. The other kind of an unusual referencing styles that, for example, in the first paper, they referenced a paper, say position 16, and they say, and the following positions. So they didn't say how many. They say, and the following ones, right? So you have to kind of go and look it up. So I haven't seen that before. I haven't seen people doing that. I usually see like 16 to 18 or 16 to 20 or 16 and 17, but not 16 and the following ones.
It's really kind of strange.
Yeah.
It's also put every reference list in order.
Mm-hmm.
And usually it for you.
That's alphabetically or yeah.
So you don't really know
what the following one is. Yeah. That's right. So in BibTeX you say this one, this one, this one, and then the BibTeX does the rest. It either lists them one by one or says the range, depending on how they ordered. Yeah.
Well, if you're using a reference that you used earlier, if you're, for instance, using reference 3 somewhere,
yeah,
and then when you're getting to reference 8, and you're going to use reference 3 again, there,
yeah.
it kind of has to do it like that. Or
Yeah.
you're using other references you're supposed to.
Yeah, that's right. So yeah, it is kind of interesting to look at the ways the referencing you will use in your own reports or your own thesis. Sometimes you have no choice, like the journal says, okay, you have to use that referencing schema. But sometimes you can decide what would work better. So
I think the fact that
yeah, that's right. So the other thing is how they referenced it. So the first paper usually just use the references as a follow-up on something. So they say, look it up here, right? They didn't really explain a lot about the actual reference they were making. Whereas with the second paper, sometimes they were explaining things and then saying, that's where we got that from. So it's sort of how it works, and this is how we know how it works from these guys, right? So you don't have to go and look it up. You understood how it works, and it was sort of only used as a reference for them to point to the source of that information. So in your own writing, you also have those two choices, right? So you either refer to something which you didn't describe, and you say you can find more information about it over there, but you don't describe it here, or you say something and you say this claim or this information is taken from there, right? So if you have any problem with it, it's not me, it's that person who I took that information from. So
in the first one, there was a couple of places he makes claims of that I thought he had some reference, but then
that's right, yeah.
I think one was about usage.
Weak, yeah. So yeah, that is true. So you should, in your own writing, you should try to avoid that too.
As far as I understand it, if you make a claim that you say this is what's true, rather have back and forth in your own research or
A reference.
To someone else's.
That's right. That's right. Exactly. That's usually the rule. It is difficult to draw the line, right? So some things appear to you as common sense, and you say it, and you say, well, it's just common sense, and it feels like you don't need to do these two things. When you do, you still have to have some form of evidence.
I guess
that's right, yeah. So there are a couple of issues. So one issue is sometimes you claim something and you have, say, 10 references supporting that claim. You don't need to use all 10. You probably should just use 1 or 2. So over-referencing might become a problem. Often when you're writing, you have a limit of how many references you can make, because you may have a page limit, and then you don't want to use up your pages for references. You want to use up the page limit for your writing and reference the minimum amount of references. In your reports and in your thesis, you don't have that. You're kind of unlimited with how many references you do. And usually what matters is the accuracy of your references. So it's not the amount, how many you have, and it's not even the ones, which ones you use. It's more how well you pick the reference to the claim which you're making, right? So if you say making some claim and then you have a reference to a textbook, it's usually very weak, because the textbook covers everything, and then it may not have the sources of some of the claims even in the textbook, right? So you should check what you're claiming, check in the textbook where they claim that and what they've used to claim that, and then reference the actual source of that claim, right? So if somebody did the research and then the textbook uses that reference to make a particular rule or claim.
There's also some things from my bachelor, which I'm referencing for formulas for equation stuff.
Mm-hmm.
And there's sometimes actually quite hard to find
the good source.
Sources, right? Because everyone is playing account, everyone knows the source.
That's right.
So I'm going back to the entire days published papers and Maxwell.
Yeah.
Some of them reference stuff 300 years old.
Sometimes if you can't find it, then you will reference a textbook. You will reference somebody who uses that form. But yeah, again, the ideal would be finding the actual source and not referencing the textbook. Yeah, sometimes, as you say, I just take it for granted. Then everybody uses them, all textbooks use them, and then you can't find who came up with that. Yeah, all right, so what else did you guys found interesting in those two articles? So I did some work on optimization. I did optimization for, not directly for mobile, but for two different projects. So one was optimizing the networking stack and making sure that the routing and what the device needs to do is done in the most efficient way on a multi-core platform. The other one was optimizing a virtual worlds updates between the clients and the server, like in Second Life or OpenSIM type environments. They were kind of two different projects, and they kind of involved a lot of profiling and a lot of measuring of what is actually happening and how you can optimize it. So one of the techniques which we use for optimizing, sure, for optimizing the networking stack was to pipelining. Do you know what pipelining is? Depending on the context, but generally some form of flow where the components are passed from one component to the other, and then they do the processing, but then the previous component is free to do what it's supposed to be doing. So we the idea was that you have, say, 4 cores or 8 cores, and then you want to utilize them in a balanced way across all the available resources. So you make them all as busy as they can, and therefore you kind of optimize the throughput through the system this way. With the mobile devices, sometimes you want to do the opposite. So sometimes you have a multi-threaded model, which sort of utilizes, say, 3 or 4 threads, and then you do that independently. And sometimes you may want to bulk it up to just have 1 thread or 1 service which does things for you and be kind of in control of how much work is done when you're idling. So when you have 3 threads, the operating system will handle that for you, right? So the operating system will schedule those 3 threads, and if you have a quad-core system, it may schedule the threads on different different cores. If you have 1 core up, then your threads will be using the same processor, and the operating system will have some overheads of scheduling your threads on that single core CPU, right? So you may want to optimize it in such a way that you actually decide what is done when in your own 1 single thread, and you optimize it yourself instead of letting the operating system context switch and do it for you. So that's one of the techniques which it's quite involved. You have to put quite a lot of effort into profiling what is actually happening to make it efficient. But generally, context switching by the operating system is not the best way to do your processing. It's an easy way because you don't have to think about how resources are being utilized and who has access to what and how things are scheduled. So it's easier for the programmer to do it, but it tends not to be the most efficient way. So if you do it yourself, then you can make it more efficient or more energy efficient, depending what your criteria are. So any of you did any profiling or optimization projects before? Like optimizing for memory or for CPU time?
Yeah, source, of course.
Mm-hmm. Mm-hmm. Mm-hmm.
I once optimized AI game algorithm for Android,
Mm-hmm.
and was working quite fast on the desktop machine, but Android it was much slower,
Mm-hmm.
mostly due to specifics of Delhi.
Mm-hmm.
And GVM handles ephemeral objects quite well.
Mm-hmm.
So it is designed to efficiently work with lots of small objects, short-living objects, with also generations in the memory moment. Garbage collecting working on that. And Dalvik is not so efficient with that, so you have to reuse your objects, do manual caching,
yes,
things like that. So it was quite, I think, 2009. So it was not a common knowledge back then.
Mm-hmm.
Everything done practice.
Mm-hmm. Yes, so object pools and reusing objects and like object factories, that's a kind of common patterns for doing Android development, where you don't generate small all the time.
Well, most developers very discouraged in Java concurrency practical.
Yeah.
And most people they don't realize this technique, but it's actually easy to get better now. With new versions of Android. The hardware get better.
Yes.
Get better. but back then it was the only way actually.
Well, so usually you only employ those techniques if you do have a large number of short-lived objects. If you have short-lived objects but not a large number of them, then you normally don't benefit that much from having pools. But for example, if you're processing packets, or if you're packing something big to a JSON structure and you're sort of generating and then disposing large number of objects at the time, then it's better to reuse the nodes or reuse some sort of structure. So one related technique is a circular queue, where you have a queue of objects, and then you're writing and reading from two parts of the circular queue, and the queue is fixed, but you kind of, as long as you don't overwrite your pointers of where you're reading from and where you're writing to, you can sort of reuse the same object pool for doing a generation of some JSON structures and or packet processing. So for some of the game programming, that is sort of necessary. Yeah. Mm-hmm. That's yeah. Yeah, and especially if you're doing anything with the low-level sensors, and you're getting quite a lot of data, low-level data, really quickly. So if you're using accelerometer hundreds, you will get 100 updates per second, and you have to process them. So you don't want to be creating any objects or disposing them and forcing the garbage collector to kick in. You want to be operating on arrays and your own memory allocations yourself and reuse as much. Yeah, that's right. So with those timescales, yeah, it's sort of tricky. And if you're doing anything like with rendering and you want to keep the constant frame rate, like for the AI algorithms for games or something like this.
So I once optimized energy consumption.
Mm-hmm.
I wrote a system similar to Android one for my desktop environment.
Mm-hmm.
So system does less CPU wake-ups. It needs to pull some data to update some widgets. To get data from internet for those widgets.
Mm-hmm.
So widgets themselves, they don't decide when do they get the data or update something. They just put it on queue,
mm-hmm.
and then the scheduler
mm-hmm.
decides. So it does it in bulk.
Yeah.
So to limit the energy consumption
mm-hmm.
for the battery.
Yeah. Yeah, makes sense. All right. So anything else for the two papers and the optimization talk? I was thinking discussing a little bit more in depth the patterns, but then I thought, yeah, maybe it's a little bit too low level. Like it may be a good thing to discuss on the 300, in the third year mobile programming course, the patterns, and here we just sort of look a little bit more into the future of what might be happening and so on.
Speaking of optimization stuff for Android specifically, one of the things I find neat about that is that you go to Stack Overflow, for example, and you stack function. So if you
Mm-hmm.
you actually find like main traders of Dalvik engine is offered.
Yes. Yeah.
That's quite neat.
That is useful. Yes.
Now you can get the source code.
Yeah. I mean, the one that's probably the one that I developed that's what's has more experience reading through it
Yeah, sure, but
yeah,
when everybody started developing Android, it was actually a great advantage that you could, if something works not like you think it should, you can just look at the source code and find what's going on.
That's true.
It's always
Yeah.
So you guys do Android development and iOS or just Android? Mm-hmm.
I've done Android and some cross-platform.
Mm-hmm. Perhaps C++?
No, actually, it's Lua.
In Lua, okay. Yeah. Makes it easier. Higher level.
Yeah, some parts, yes. Some parts.
Roman apps.
Hmm?
Roman apps.
That was why.
Mm-hmm. All right, so I think I will shut that, and we will plan for next week.